The following video is about geometric sequences. If a sequence can be defined by an exponential function, then it's a geometric sequence. Probably shouldn't have that many sequences. It is a geometric sequence, and it is said to have a common ratio. So let's talk about general formulas for geometric sequences. If it is explicitly defined, that means we have one definition, and it works for all values. So a sub n is equal to a sub 1 times r to the n minus 1. R is the common ratio, a sub 1 is the first value in the sequence, and then a sub n are any subsequent values. A recursively defined geometric sequence means you have to have two definitions. So you have to have the definition of the first term, a sub 1, and then you have a sub n is equal to whatever the previous term is times your common ratio. Number one, find both a recursive and an explicit formula for the geometric sequences below, and then find the 10th term. So a recursive formula is one that you define the first term, and then you define all subsequent terms thereafter. So a sub n is equal to whatever the previous term is times whatever the common ratio is. And if we look at this, the common ratio appears to be -3. So if we multiply all of these terms by -3, we end up getting the next one. So r, in this case, is equal to -3. So a sub n is equal to -3 times a to the n minus 1. If I wanted to define this explicitly, I would say a sub n is equal to -7, which is my first term, times the common ratio, which is -3, to the n minus 1. So this is defining it all in one shot. Now a sub 10 would be -7 times -3 to the 9th, because if I plug in 10, I get 10 minus 1, which is 9. And that would end up being -137,781. I can also find this recursively if I found each term in subsequent or in sequence. So -7, 21, -63, 189, and then I keep going and I find the 9th term. Then I take the 9th term times -3. So I could find it in a recursive form as well. This one would recursively be defined as a sub 1 equals 48, and then a sub n is equal to the previous term times whatever my common ratio is. And it looks like my common ratio is 3/4, because if I multiply all of these things by 3/4, I end up getting the next one. So this would be a sub n equals 3/4 times the previous term. Explicitly, I could define this as a sub n equals whatever my first term is, which is 48, times 3/4 to the n minus 1. Then if I want a sub 10, I'll do that explicitly because it's easier. 48 times 3/4 to the 9th. And then when I plug that in, I get 59,049, it's a 0, over 16,384. Now, when would it be easier to use the recursive method? Well, let's say I wanted the 5th term. If I wanted the 5th term, all I would have to do is take whatever I know, which is the 4th one, then multiply it by 3/4. So I could have 243 over 16 as my 5th term. Recursive or explicit, it kind of depends on how many terms out you are and how many terms you know and other things like that as to what's easier. Number 2, find the 7th term of the sequence 4/5 to the n. Well, the first term would be n equals 1, that's 4/5. The second term would be n equals 2, that's 16 over 25. Seems like recursively, I would have to do a lot of work in order to get there. So all I would have to do is plug in 7, and that would get me the seventh term of this geometric sequence. So that'd be 16,384 out of 78,125. Now you may be thinking, this doesn't look like the explicit form of a geometric sequence. Well, what is n equals 1? A sub 1 equals 4/5. So I could still define this as a sub n equals 4/5 times my common ratio, which is 4/5 to the n minus 1. But what is 4/5 times 4/5 to the n minus 1? That's just 4/5 to the n. So that's what's going on there. Problem 3, find x so that x plus 2, and x plus 3 are the first three terms. So a sub 1 equals x, a sub 2 equals x plus 2, and a sub 3 equals x plus 3. So notice that a sub 1 times r is going to get me a sub 2, and a sub 2 times r recursively is going to get me the next term, right? A sub 3. So I use the recursive definition here to kind of figure out what's going on. And what I then notice is that if I use these two equations, I realize that r equals a2 divided by a1, and r also equals a3 divided by a2. So I can set these two things equal to each other. Well, I already know what a1, a2, and a3 are. So r is equal to x plus 2 over x, and it's also equal to x plus 3 over x plus 2. So now I'm going to solve the proportion, multiply using a method that is commonly called cross multiplying. So I end up with x plus 2 squared equals x times x plus 3. X plus 2 squared is x squared plus 4x plus 4. X times x plus 3 is x squared plus 3x. Now I'm going to subtract some things. So x squareds go away. Subtract 3x. And subtract 4. I get x equals negative 4. Let's double check to make sure that this makes sense. And it certainly does. So what seems to be happening is that r is equal to negative 1/2. I'm sorry, positive 1/2. So r is equal to positive 1/2 because if I multiply each of these terms by 1/2, that seems to be the common ratio. Also, if I put negative 2 over negative 4 or negative 1 over negative 2, what I notice is that that's 1/2. So to find the fifth term of the sequence, it's probably easiest to do this recursively. I get negative 1/2 and then negative 1/4. So a sub 5 is equal to negative 1/4. Finally, find the fifth term in a geometric sequence in which the fourth term is 4, the sixth term is 6, and the common ratio is negative. Well, I know that r, just like in the last problem, r is going to be the same thing as if I have common I have a common ratio going on. So a sub 6 is really the same thing as the previous term times r, and a sub 5 is really the same thing as the previous term times r. So what I'm going to do is I'm going to take 4, plug it in for a sub 4. I'm going to take 6, plug it in for a sub 6, and then do some cross multiplying. So 6 over a sub 5 is equal to a sub 5 over 4. Cross multiply, I get 24 equals a sub 5 squared. Then I take the square root of both sides. So a sub 5 is equal to plus or minus the square root of 24, which is equal to plus or minus 2 square root of 6. Since it tells me that the common ratio is negative, I would have to take the negative term. So a sub 5 is equal to negative 2 root 6. And if you wanted to find r, you could. It doesn't ask for r in this problem, but we could find r. So I know that a sub 5 divided by a sub 4 is r, or a sub 6 over a sub 5, but I'll do it this way. So negative 2 root 6 divided by 4 is negative root 6 over 2. That would end up being my r in this problem. And if I double checked it, if I take negative 2 root 6 and I multiply it by negative 6 over 2, I end up with negative root 6 times root 6, which would be 6.